Hello, this is Dr. David Kordowitz and welcome to Solidworks. Today we're going to be covering some of the 3D building tools which will help you convert your two-dimensional sketches into three-dimensional parts. We'll be covering a number of different tools that can be used for a number of different situations. Let's begin. Our three-dimensional tools can be found on the Features tab of our Control Manager up top, and you can see right now we have Extruded Base Boss and Revolve Base Boss showing, and a bunch of other things grayed out. This is because these tools can be used to make initial base bosses and will bring you into automatically making a sketch. However, we're going to start by creating a sketch the way we've covered in the past. So I will right click, say on the front plane, and hit Create Sketch. Let's quickly go over again. We're going to make a rectangle here, or rather a square. So what I'm going to do first is use the rectangle tool, and now I'm going to use a smart dimension to dimension my square. So let's just say 80 millimeters by 80 millimeters. So once we're done with this, now we have a two-dimensional square that is sitting on the front plane. So what if we want to make it three-dimensional? Well, now we can go over to our Features toolbar again, and you'll notice you have a few other things highlighted. Well, namely, we have our Swept Base Boss available. Well, it depends on what we want to do, which tool we choose. Our three-dimensional tools can be found on the Features toolbar. Our three-dimensional tools can be found on the Features tab of the Control Manager up top. We currently have available to us Extruded Base Boss and Revolve Base Boss. The reason that these are available but the others aren't is that these two can use a single sketch to build them and will thus bring you automatically into a new sketch if you should click on them. However, we're going to start sketching the same way that we covered in the previous videos. So we're going to start on the front plane, and I'm going to right click and choose New Sketch. And now I'm going to go ahead and draw a square. So to do this, we choose the rectangle tool, and we pull it out. And we can use our smart dimension here to dimension it to say 80 by 80. Now we want to turn this into a three-dimensional cube, for example. So if we want to make a cube, the method we would want to most use is taking that square and pushing through it and creating that square on more and more z-directional levels. If you think about it, it's sort of the same idea as squeezing toothpaste out of a toothpaste tube. It maintains that round shape of the nozzle on the toothpaste tube as it comes out of the tube. This is what we call extrusion. So if we come over here to our Extruded Base Boss now, I can click on that, and what you'll notice is all of a sudden everything sort of turns around, and I've got this yellow area along the part that we had started creating, along the sketch. This yellow is the third dimension. We have a number of options here in Extruded Base Boss, but for simplicity, if we leave it the same settings and we change our D1 to 80 millimeters, we will get it extruded out 80 millimeters, and we can click the OK button up here, and we now have a cube. The wheel on your mouse can be used to zoom in and out. If you click the wheel and pull your mouse around, you can rotate your box any way you want. Now this is where the standard drawings toolbar comes in handy. We have a bunch of different standard views. So we have our front view, our back view, our left view, right view, top view, and our bottom view. We also have our isometric view, which is a standard view in drafting. We have our trimetric view and our dimetric view. So we can set to any of these that we'd like, and we can use these to sort of look at our part in different directions. Now, a few interesting things with extrude and with sketching. So we now have this base here. It's just a piece of material. Right now we haven't even said what material it is. But we can then continue sketching on one of the faces of this. How do we do it? Simply right click on the face, and then we can choose New Sketch to begin our sketch. If you notice, I have on the top, I have edit sketch, and then I've got sketch down here. But I'm going to click on new sketch, and what that's going to do is open a sketch on that surface. Now it's at a weird angle, and I probably want to look at it closer so that it's straight on with the screen. To do this, I simply come up to my toolbar and I click normal to. Once I click that, everything flips into the same direction I'm in. So let's say, for example, now I wanted to base my drawing on the boundaries I have here. Well, it turns out that these boundaries are not in my current sketch. They are the base and the plane that I'm drawing on, but they are not in my current sketch. To bring them into my current sketch, I simply go to Convert Entities, and then I can click on the square. Once I click OK, that square has now been brought in as lines in my current sketch. Let's say now I want to make this a smaller cube that's going to sit on top of here that is 40 by 40 by 40. So all that means is I'm going to move each of the edges in by 20. So to do this, I can go ahead and hit Offset Entities and pick the entire chain of lines, and then we're going to reverse it because right now it's going outside the box. So we're going to reverse this and type 20. And we're going to click OK. Now what I want you to notice is there's two different colors of blue here. Because the outermost frame and the innermost frame are here, if I try to extrude this, what you're going to end up with is this innermost area is going to be not extruded, and you're going to end up with a frame. So for example, if I click on Extruded Base Boss, you can now see that we end up with a frame. However, if we want to end up filling just that center box, there's a couple of different ways to do it. Probably the best is to convert the lines that we had converted over to construction lines. To do this, just simply right click, and we have a tool over here that looks like a solid line and has two arrows and it goes to a dotted line. If we click that, what it's going to do is it's going to convert those lines into construction lines. So now it's a little hard to see, but they're dotted. Now we can go back and extrude our base boss. We said this is 40 by 40, so we want this to be 40 high. And we say OK. And we now have a 40 by 40 by 40 cube sitting on top of my 80 by 80 by 80 cube. So this is a really convenient way to build certain geometries. However, this is kind of a slow and clunky way, especially if you're going to build things that are symmetric. So when we're working on things that are symmetric, say a sphere or a ball, we're going to use some of our other tools. So let's begin a new part, and we're going to make a ball. All right, so let's start here by simply going on the front plane. So we're going to do a sketch on the front plane. And the first thing I'm going to do here is draw a line. So this line, let's use a midpoint line. And so I'm going to click on the origin, and then I'm simply going to draw up and down to some length. And there we go. So we have a midpoint line, and we can define the length of this. And right now it's at 129. Let's go with, say, 80 again. So what this is this is a line that goes around the center. Now, if we think about it, we can use what we call our revolve tool to take a wedge of the ball and revolve it around some center line. So what I'm going to do is use my tangent arc to go from the top of this to the bottom of this. And what that's going to do is that's going to give me a half a circle. This half a circle then, if I take this and I spin it around on this line, on the center line, will give me a ball. Now, it's important to note that if I had drawn a whole circle, when I got to 180 degrees, the ball from one side would be coincident with the ball on the other side. This, therefore, won't let you do that. So let's go ahead quickly and do a revolve base boss. And we're going to choose this center line to rotate about. Now you notice this is a sphere here now. So if I click OK, I'm going to end up with a sphere or a ball. And I can drag this around and look at it. So this is a very efficient way to build things that have total symmetry, particularly things that have roundness to them. So what if we want to do something that has a path about it, say putting an edge onto an object or something like a curved railroad track? Today, what we're going to do is look at a curved I-beam. So we're going to start by creating a new part. So I go ahead and create this new part, and the first thing we want to do is we want to think about what the contour of the shape is, or what the outside of the shape is going to look like. So I'm going to take the front plane here and start a sketch. We're going to go ahead and draw an I-beam, but the first thing I'm going to do is create a center line coming up from the center point here, going up, and then I'm going to also create a center line going out to the right. This is going to help us for using symmetry in a moment. Now, if we think about an I-beam, or the capital letter I for that matter, we know that it's symmetric in both the X and Y directions. This can come to be beneficial because if you remember, we can use our mirror entities to do a lot of our geometry. So the first thing I'm going to do is draw the rough shape of my I-beam. So we're going to go ahead and do that, and we're good. One thing I'm going to do is I'm going to take this point here, that's the end point of my construction line, and I'm going to take the point that's the end of my bar, and I'm going to go ahead and merge them just to make sure that everything stays connected and that we have no stray ends. Now we're going to use our smart dimension to define our shape. So we're going to say that the thickness of this beam is somewhere around, say, maybe 2 inches. And that's going to define the thickness of the beam overall. Now, what we want to do also is define the width of the beam, and we're going to say that the width of the beam is about 6 inches-ish, maybe a little bit bigger. So let's say it's 8 inches, so we can then say half of it is going to be 4 inches. We can set that. And then we're going to set the thickness of the beam here to the same thickness we had before, so 50.8. But remember, since this is the center, we're going to divide that by 2. And then we're going to say that the height of this entire structure here, so this entire I-beam, is going to be, it'll be 8 inches total, so we're going to say 4 inches. And you'll notice it's kind of short and squat, but once we do our mirroring, it's going to look right. So we need to do 2 mirrors here. If you notice, everything is fully defined now. So we need to do 2 mirrors. So the first thing we're going to do is select all of our parts here on this side, and then we're going to mirror that about the x-axis or the y-axis, in fact. So we're going to click on this, and it's going to flip it, and you can see the guideline over there, and we say OK. And now we're going to do a second mirror to get the other half of the beam. So we're going to do mirror entities, and we are going to select all of the lines that we have now. And then we're going to mirror across the dotted line that we have down at the bottom. So we're going to set a mirror about and mirror it about there. And if you zoom out, you can see what we've got. So we click OK. And in doing that, we now have an enclosed space. Now, if I were going to do a traditional I-beam, I could go ahead and extrude it straight out, and I would have an I-beam. But in this case, we want to go ahead and do something a little more complicated. We want to add some curvature to it. To do this, we're going to use the swept base boss. But to use a swept base boss, we have to have 2 separate sketches that are perpendicular. They're in different planes from each other. So we're going to go ahead and exit the sketch, and we'll have an outline of it there. And what we now want to do is pick a plane that's perpendicular to that. So if we look at it, we were on the front plane, and I think for this one, we're going to go with the top plane. We could also go with the right plane, but because we want to stay with the I-beams front facing forward, we're going to go ahead and go on the top plane. I'm going to hit the normal 2 buttons so that we're looking in the right direction. And now we want to draw the path. So let's say, for example, I want to draw a semicircular path. So I can use a 3-point arc, for example, and go from the center here, and I can go to wherever I want. So I'm going to say to like right about here, and then we're going to stretch this thing out a little bit. Now, one thing we do want to make sure of is that the radius and all of that are large enough that everything's going to be able to fit. So we're going to set this radius to, right now it's at 49 millimeters. Let's set this to like a 10-inch radius, something relatively large. And Then we're going to set, say, the height difference here to maybe 6 inches or something like that. And the width difference here should be already fixed, but we'll go ahead and do that anyway. So 435.2. And so now we're fully defined again. If you notice, we're starting out down here at this I-beam, and what we're going to do is we're going to take this I-beam and we're going to pull it along that track, along that path. So let's go ahead and exit this sketch. And now what we're going to do is go back to our features menu and choose swept base boss. So we have two parameters that go into our swept base boss. The first one here, if you notice, we have a grayed out path but a lit up contour. That's going to be our contour. So to get to that, we're going to go into our flyout design tree, and we're going to pick the sketch that contains that location. The next one is going to be our path, which was automatically selected because it was our last worked on sketch. So you can now see that we have a yellow line, and it's basically an I-beam that's bent on that path. We have a few other options we can set here. So we can set things like following path, or you can say keep the normal constant, which in this case won't work because things overlap, but that allows you to keep the normal of the face straight. You can add twist if you'd like to. You can also set your start and edge tangency to make the directions correct and to make everything fit correctly. There's also a number of other little tricks. You can use guide curves. A guide curve will actually allow you to show where the outside of it's going to be. But this is all I want right now. So I'm going to click OK. And what's going to end up happening is I'm going to end up with this beam here that follows the contour that I set. Now this contour can be as complicated or simple as you want. This is all about making sure that you have the right shape for what you need. So now we're going to go to something a little more artsy, if you will. The concept of lofts is a little more complicated, and we're going to look at them really quickly. They are not on the CSWA, but you will need them for a number of projects, and you may use them on the CSWA. So let's go ahead and create another new part, and we're going to look at lofts. Lofts use what we call reference geometries. So the idea with lofts is that we're going to build a series of planes that are parallel to each other with what the shape is going to look like at that plane. So let's say I go ahead and start here, and let's start with a simple circle. So we can start drawing our circle here, and that circle is going to be of some radius. So we want to fully define it. So I'm going to say maybe that this is 100 millimeters. And then let's say OK, because that's what our entire contour is going to look like on this plane. Now exit the sketch. Now what we need to do is create the next plane. To do this, we're going to go into the reference geometry menu, pull down, and we're going to choose a plane. To do this, we're then going to have to pick the plane that this is in, so that's going to be the front plane, and it'll be parallel to it, and we can set a distance, how far away we want. So let's say 200 millimeters away, and we're going to set it even to it, and we'll actually make two planes instead of one plane. So there's going to be one at 200 millimeters and one at 400 millimeters. So if we click OK, I can now take this and tip it, and you'll see that there are separate planes. We need to keep our plane straight when we're going through this and know what is where. But we can right click on the plane or on it in the design tree and create sketches on each plane. So let's say in this case, we're going to go ahead and make this next one a polygon, which we're going to start at the center, and we're going to come out and make the radius the same as the circle. Let's make it a 8-sided polygon, just like this, and we're going to say OK. Now what I'm going to do is take this circle that's the inner circle here, and we're going to take our circle from the previous one, and we're going to make them co-radial, which means we're going to make them on the same circle. Next, we're going to take this center point, and we're going to take the point out here and make those vertical. This should fully define this plane. So now we've gone from a circle to an octagon, and we're going to go ahead and close this sketch. And now we're going to create a sketch on plane 2. Plane 2 is the next one. So if we look at it, we have our sketch on plane 1, we have our sketch on the front plane. So let's go ahead and create a sketch on plane 2. And we're going to go normal. We'd like to stay normal. And we're going to make this one a rectangle. I'm going to switch to center rectangle so I don't need to worry about where my center box is. And we're going to go ahead and just pick, say, these 4 corners, just like that. And by doing that, everything is fully defined. We're happy. So if I exit the sketch now, I can sort of pull this to the side and, oh wait, we put that in the wrong sketch. So we can undo that by just Control Z. And we're going to exit the sketch again. And now we're going on to plane 2. And we're going to create a new sketch on plane 2, sketch 3. And we're going to do exactly what we just did. So we're going to create a center rectangle. And we want to make sure that it hits that point, just like that. And now we're fully defined. And we're going to exit the sketch. If you notice, all my sketches are fully defined. If I pull out, you can see these different shapes. So let's create a loft now. So we're going to choose a lofted base boss. And with the loft, we have to choose the contours. We have to choose the order they're going to go in. So let's start down here with this circle. So we're going to click on the circle, and that's going to set the first sketch. Now if I click on this octagon here, what's going to happen is it's going to pull that contour from my circle so that it's an octagon when it gets to that point. Now finally, I'm going to choose the square at the end. Now, if you notice here, there's quite a bit of twist. And the reason there's twist is because we're following this green line here as to what parts of the circle, square, rectangle, octagon, those sort of things connect to each other. And since we don't have this center point on my rectangle, I need to move this handle down to the next point that we do have. And that should reduce the twist going from the octagon to the square. Now we still have twist going from the circle to the octagon. All we need to do is move the thing to make it a straight line, and that twist should more or less go away. And you can keep tinkering with this to make it even better. Now when I'm done, I can click OK, and what's going to happen is we're going to get an object that follows those contours that's smooth. This smooth object is what we call a loft. We've connected a whole bunch of different objects in the series. So now a couple of things to do once we have drawings. One thing we can do, or models. One thing we can do is we can use the fillet tool. And the fillet tool is going to allow us to round edges. So we can come up here and round, and round, and round, and round. And what we can do is set the radius. So right now our radius is 10. Let's change it to maybe 5 because we want a little bit less of the effect. And we're going to say OK. What's going to happen is it's going to make a smooth edge on that so it's no longer sharp. Filleting is really useful when you're designing objects to make them safe to handle, to make them look better, and to make them work better. Remember though, when you're looking at a diagram or something that you're working on, those fillets are actually quite important because they take away mass. They add or take away mass, depending on how you have your fillet set. So one last thing to look at is how do we find out the mass of this part? So the first thing we need to do is we need to assign it to a material. So right now it's assigned to some generic material, but I'm going to go ahead and change it to, say, 1060 alloy, which is a steel. The first thing you'll notice is that the visual look of it has changed. That's because it is using, on my computer, what's called RealView graphics. You may or may not have access to RealView. There are some articles out there on how to turn RealView on a computer it doesn't work on. Look on GrabCAD and things like that. But I'm using RealView, so this is kind of what it's going to look like when it's a finished product if I made it out of this 1060. Now to get to things like the mass, we're going to go to Evaluate. In Evaluate, we're going to click Mass Properties, and it will bring up this screen. If we notice, it gives us the mass here in grams. It gives us the volume in cubic millimeters. It gives us the surface area, and it gives us the center of mass. The center of mass will help tell sort of where the heaviest part of the object is or where the balance point of the object is. while the overall mass is going to tell us how much the project's going to weigh. Every assignment you submit in this course, you're going to have to provide me with mass for your parts as well as for your assemblies. The reason for this is even a small mistake in your drawing will cause a shift in mass, and this is how the CSWA will grade you on your parts and assemblies. So be aware that this is here, and be aware this is how you get to it. So that's all for today on simple parts. We will continue forward with a little more detail on how to do different types of 3D objects, as well as how to do visualization in the next video. Thank you for your time, and see you next time.